Hi, my name is Brad Kramer with Prevainio Consulting, and today I want to talk about lower explosive limit and upper explosive limit, or LEL and UEL. LEL is the lower explosive limit. That's how much you have to have of a certain gas in the air before it will combust. The upper explosive limit is going to be the most that can be in the air before it combusts, because basically it's going to choke it out. Think about if you understand like the difference between gasoline and diesel engine. If you have a gasoline engine, what happens if you have it set too rich? That it's not going to fire off because you have too much fuel in the chamber. So it's not going to have enough oxygen in that mixture, so that's too rich. It's not going to burn. LEL means you don't have, below the LEL, you do not have enough of the substance in the air to ignite. So again, if you have that engine set too lean where it won't even fire over, you can crank it over and crank it over. It won't ignite because there's not enough fuel. You want to set that engine to be right between the LEL and the UEL, right? So if it's too rich, it won't run right. If it's too lean, it won't run right. So we're going to look at that, looking at a bottle and some butane. So butane has a lower explosive limit, right around 1.5%, and a UEL right above 8%. So if you have more than 8% of this in an atmosphere, it won't ignite. Less than 1% of this, or a little bit more than 1% of this in the atmosphere, it won't ignite. This also has a vapor density of almost twice the weight of air, so it wants to sink. So if you were like me when you were kids, you probably did a few naughty things and maybe take a butane lighter and either put it in your hand and ignite it and watch the flame come out, or put it in a plastic bottle and go make yourself a little jet engine, right? So we're going to do that with a glass bottle here. It's not going to get hot and melty like plastic bottles will. So right now there's nothing in it but air. So right, if I put my lighter in there, you can see it's burning. So what I'm going to do here is I got a little bit of butane fuel. I'm just going to spray it in here very carefully. All right, so I got some going in here, and I'm just going to turn my fan on just for a minute to clear away any vapors. All right, so this cleared out any vapors that may have built up around me here, but we should still have some butane in the jar. So what we're going to do is I'm going to put the lighter back in here. Saw a little bit of flame at the top there, but it doesn't really want to burn. Now if I put this in here, the lighter's not igniting. That's because there is too much butane in here. We are above the UEL inside here. But watch what happens here. Okay, it won't light. Won't light. I turn it upside down. Oh, it's going to stay lit, all right? That's because this is filled with butane gas. And what's happening is because it's heavier than air, that butane wants to flow out, and it gets towards the bottom of the bottle, and it's going to light. And what would happen is if we turn it up, it's going to go out, simply because the butane wants to settle down to the bottom where it's going to be too rich to burn. So again, if I put the lighter in here, nothing's happening. So if we were to sit here and watch this for long enough, and I don't want to hold it too long here, otherwise it's going to get a little bit hot on me, but what would happen is we'd be sitting here watching it, and all of a sudden it'd go poof, and you'd see the flame front go in there. That's because it would consume enough of the gas in there that now we would have that perfect mixture right in there as the flame front goes back in there and eats away at the fuel. That mixture would be between that 1 and 8%, which is where it will ignite. Now you want to be careful doing this, that you don't do something like acetylene, for example, has a very wide range. It'll ignite 1% up to about 99%. So if I was going to put a little bit of acetylene in here, it would all combust, and if you put enough in there, I don't think this bottle would be have enough escape for that pressure, so it could explode on you. That's why I'm using something like butane that has a nice narrow LEL to UEL, so it works out good for this experiment. So for example, we can still see it's burning. I'd actually have to sit here and let this bottle just air out, preferably pointed downward, so it would get enough air in there to let enough of that escape. But she's still burning, still coming out. So quick explanation on lower explosive limit and upper explosive limit. That's exactly how I teach it in class, hands-on and showing how it's going to impact you on the job.